We have discussed various reasoning mechanisms elsewhere. In this video, we're going to discuss 5 different types of reasoning. Okay, we have briefly discussed 1 or 2. The very first one is deductive reasoning. Okay, to deduce, infer, extract new information from logically known information. Okay, a deductive argument offers statements, okay, that lead automatically to a conclusion. So, for instance, you could say if there is dry wood and oxygen and a spark, there will be fire. This is a logical conclusion, deductive, deduced. So, given that you need to have dry wood and you need to have oxygen and you need to have a spark, so we deduce that there will be fire. All men are mortal. Socrates was a man. He is a man. So we can deduce that Socrates is mortal. Inductive reasoning. Induction means to generalize. This is based on forming or inducing some probable conclusion based on limited number of information, statements, propositions, okay, as opposed to deductive. So you could have an observation, of course, in the form of a statement, that all crows that I have seen in my life are black. So I can conclude that all crows are black. However, not all crows may be black, depending upon various other areas. Okay? Or, as we said earlier on, you ask a few children about their homeworks, and based on their answers, you could say, homework is very easy. And you can generalize, but you only have statements from, let's say, 4 or 5 different children. So this statement, this conclusion is probable based on the inputs from only 4 or 5 children. Now, if this were 500 children, your conclusion may be more probable. So deductive versus inductive. We conclude what will happen when we let go of a ball and then see what happens with the, in this example, with the deductive logic and inductive logic. Inductive reasoning. Okay, so when you let go of a ball, by experience, every time you know that you have let go of a ball, it always falls down. Okay, so you can conclude that next time I let go of the ball, it will also come down. So this is based on your experience and observation. Now the same thing, if we were to analyze using deductive logic, you wouldn't worry about your experience. What you will do is you will use Newton's laws of gravity. And since you know that everything is attracted by Earth, by gravity, so whenever you let go of a ball, it will fall down. You don't need any evidence, so to speak, for that. So deductive reasoning is based on something else, like rules, and inductive reasoning is based on your observations. So experience versus rules. Deductive reasoning will always lead to a correct conclusion. Inductive reasoning will lead to a probable conclusion. Now comes the third type, abductive reasoning. Plausible inference. Deduction is exact in the sense that deductions are always logically true. Abduction is a form of deduction that allows for plausible inference. Okay, conclusion that might be wrong as well. Right? Now that's very interesting. How can that be? consider a situation where you have a conclusion which says she carries an umbrella if it is raining. Fair enough. Now, if we are given a statement that she is carrying an umbrella, you conclude that it is raining. Now, this conclusion that it is raining is plausible. It could be wrong as well. And why is that the case? Because she could be carrying the umbrella and it's not raining, but she's carrying umbrella because the sun is too hot. It is very sunny. See? So this is the difference. This is a logical conclusion. But this is a plausible, something which is not entirely correct inference. Okay? She could be carrying an umbrella due to two reasons. One of which is given here, that it is raining. So if it's not raining, what is the other situation? That is that it is sunny, it's strong sun. So this is what is meant by abductive reasoning. Analogical reasoning, analogy, similarities. Analogical reasoning, once again, is very common in everyday life. You work by comparing similar situations and you look for similarities and differences. So you could say that, driving a truck is just like driving a car. There are some similarities, of course, but then there are specifics as well. But this analogy is comparison. It's what we call as analogical reasoning, similarities. And then, of course, as I said, there are certain distinct features between the car and the truck. Another form of reasoning is called non-monotonic reasoning. What does that mean? A new word. Monotonic relates to the word monotony. Okay, and that relates to time. Non-monotonic is used when the facts of the case are likely to change after some time. Non-monotonic. Okay, monotony means no change. So in terms of time, things will remain the same. Non-monotonic, things will change over time. A very simple example. If the wind blows or if the wind is blowing, then the curtains, they will move, they will sway, right? Now this is, a straightforward conclusion. Now consider what happens when the wind stops blowing, stops moving, right? The wind. Now should the curtains also stop moving, stop swaying? That is the question, okay? If you are working in a system which is non-monotonic, okay, then the curtains should stop as well. But if you are talking about monotonic reasoning, which is monotony, then the facts won't change, okay? So if you defined once that the wind is blowing, in that system, okay, even if you remove that fact, okay, the result will still remain the same. In non-monotonic reasoning, we have a truth maintenance system that actually keeps track of what causes one fact to be asserted, okay, one conclusion to be made, and it keeps backtracking to the source of that. And that source goes away, then the conclusion also is actually negated. That is what is non-monotonic reasoning. Very simple. Once again, the next type I'm going to discuss is common sense reasoning. And you say, why are we discussing these? Are we just trying to highlight different forms of reasoning? Common sense reasoning, which you do every day. This is essentially an informal reasoning mechanism. And we actually use the knowledge that we have gained, the rules of thumb, sometimes called, okay, over years, over experience, we used to we apply them to infer new information. And this is based on the heuristic knowledge, okay, knowledge out of experience, rules of thumb. So if you talk to, let's say, a car mechanic, and you say that I switch on the battery, okay, but the car doesn't, the ignition doesn't start. The first two things they'll ask is, do you have petrol in the car? And the other is, there's a problem with the battery. Okay, so these are the rules of thumb that he has learned, developed over time, and that's why it's called common sense reasoning, knowledge-based reasoning. Knowledge-based reasoning, compared to others, is simply an essential difference. Numerical or image processing essentially manipulates numbers. When you are given an image that is translated into pixels and the value of the pixels, and then you put them in terms of those numerical information, and you process them to find out whether those pixels really are the contours of the picture that you're given. That's number crunching. Okay, and this kind of knowledge-based reasoning is actually number crunching. The knowledge-based reasoning that we come across manipulates symbolic information using AI principles. And symbolic information is more qualitative than numeric information, which is quantitative. Okay, in everyday life, we are more used to qualitative rather than quantitative. If you're given certain numbers, symbolic information is more qualitative. Numeric information is quantitative. For instance, 6 feet tall or 5 feet tall or less than 5 feet. So each of these heights can relate to small, medium, or high. Okay, but these are numbers. If we were to represent them in qualitative form, you would say tall, medium, and short, which is what we do every day. Okay, then you have qualitative representation as good, bad, high, low. The food is delicious, the food is bad. Okay, this is qualitative. Okay, you don't have specific numbers assigned to them, and human beings are very good at this, as opposed to, you have temperatures like 15 centigrade, 30 centigrade, 40 centigrade. These are just numbers. Yes, these are numbers, but as a human being, we would rather say it's very hot when you see 40 degrees, or when I say 40 degrees, it could well translate into 41 degrees or 39 degrees. Okay, so there's the relationship. So we are very good at that's qualitative. The quantitative are those numbers. Okay, so what we're saying is that knowledge-based reasoning is more concerned with qualitative, symbolic information as opposed to quantitative. I hope this was interesting and useful. Thank you very much.